Hi guys, and welcome to this video on the language of algebra, the start of a algebra series here on mathsguru.com. Hopefully you're going to find this useful. I love algebra, but teach it in a very, very strange way, as lots of people do, and they say, what do you mean? I go to Kissy-Kissy's and bunk beds and prison guards and whatever else. So you're in for a treat, because maths got to be rememberable. It's got to be rememberable, hasn't it? We've got to have stories behind this, and that's how I tend to teach. Right, understand basic terms. What are we going to look at? That's what I'm doing. Understand what the basic terms are. Identify coefficients, terms, constants. What's an expression? What's an equation? And write equations from Worded. Yes, now I'm following the Cambridge Essentials textbook series, and thank you, Cambridge, for allowing me to use your stuff. Freaking awesome. Now, algebra is going to be used forever. This video is aimed at year 8, and obviously you're then going to be using it in 9, 10, 11, 12, and probably from thence on. You're not going to escape it. What is algebra? It's using letters to stand for numbers, pretty much. And a lot of people go, I hated algebra at school. If you ask your mum and dad, I hated it, didn't understand it. Well, hopefully you're going to be able to teach them by using Kissy-Kissys and bunk beds and whatever else. Okay, so the language we are going to use is algebra, so we use letters. And basically, I always start with the idea that, you know, he says, writing in highlighter again, that the letter A basically stands for anything you flipping want to. Generally speaking, it stands for a number, it's in the place of a number. But this here is basically called a pronumeral. Now, if you're in the UK watching this video, you'll be going, oh, what? Yeah, exactly. I think I taught there for 20 years, never used the term pronumeral whatsoever. Maybe a variable, yes, but never a pronumeral. All right, so a letter is a pronumeral. Thank you very much. And it can stand for anything you like. So in one question, I may say, well, let the A stand for 3. Now, that might be that the cost of apples is $3. It might be that I've got 3 Adams in a room. I don't know. But one of the things I tend to do is I let A in my head stands for something, apples. So with all the letters we could have apples and bananas and carrots and ducks and eggs and Mr. Letter, goldfish, whatever. Yes, so just realize that algebra is a letter is in place of a number. Thank you very much. So that's a pronumeral. What else do we have? We have a constant. Now, what is a constant? Well, constant means it doesn't change, right? So generally speaking, constants in this are just numbers. Now, you're going to turn and say, well, hold on a moment, you said letters could be numbers. I did, but if I had something like this, where I had x plus 3, then one of those is a pronumeral and one of those is a constant. Oh, which one do you think is the constant? This one here is the constant. Now notice I've highlighted the plus as well. Really, really important in algebra. So this thing here is the constant. It doesn't matter what the value of x is. That plus 3 stays as plus 3 in every single question, yes? So here is my pronumeral and there is my constant. Now, because maths is maths, we want to try and throw in all sorts of other stupid language. X plus 3, written like that, is also known as an, expression. So when we have lots of letters and numbers and all pluses and minuses between them, and maybe fractions, what have you, it's an expression. That is different from an equation. Now you might turn around and say, oh, what's an expression? What's an equation? Well, I'm about to show you. So x plus 3 equals 7 is an equation. And you're going to turn around and say, well, hold on a moment, it's still got x plus 3 in it. I went, yes, it does. But it also now has an equal sign. So an equation has an equal sign in it. An expression does not. And generally speaking, equations can be solved, where we can find the value of the missing number. And in this situation, if you go a number, all right, so if we think of this as just a number, plus 3 is 7, hopefully there you will now know that the value of x in that equation, x must be 4, because that's the only way for these two things to actually be equal, yes? Now what we've done there is substitution, which we'll come back to a little bit later on. So it's very important to realize an expression has no equals. All right, so we've got pronumerals, constants, expressions, equations. What else does it want us to know about? Coefficient, oh shucks. Right, okay, so a coefficient. Right, I'm going to write down here 3x. Now, when I go shopping, I get really, really lazy. If I want 6 apples, I could write down on my shopping list one an apple and 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 an apple. But who is going to do that in real life? Yes? We try and find a shortcut to be able to help us write that in an easier way. So in that situation, I could shortcut it and say that is the same as 6 apples. Oh, so here what I've got is 3 xylophones, right? It's just a shortcut notation, or 3 lots of a number, because again, remember that X stands for a number, but again, in this situation, I'm going to call it a xylophone. So that's 3 lots of a number, and there's the 3 lots of a number. All right, so does the 3 have a special name? Well, yeah, it is. Yep, that 3 is called the coefficient. So a coefficient is the number in front of a term. And you're going to say, hold the phone, what's this term business you've been talking about? Well, other than the fact that we are at terms for school. Oh, have you noticed? Right, now Barry, who I hate with a passion, is the guy who's responsible for making all this stupid language in maths. He had a field day in algebra. All right, what is a term? So if I had something like 3 apples and 4 bananas and a carrot and, I don't know, 3. Now again, that's a constant. So you notice here, what have we got? We've got here is a constant. We know that's a constant. We've got a pronumeral. We have another pronumeral and another pronumeral. So there are 3 pronumerals, all different. All right, so I'm going to write pro. We notice we've got a coefficient there. And we have a coefficient there. So what's a term? Well, a term is anything that's separated by a plus or a minus. So this thing here is a term. That is a term, that is a term, and that is a term. And again, it is critically important that you notice that I have highlighted the plus with the 3, the plus with the C, the plus with the 4B, and the 3A. Now actually there is a plus in front of that 3A, but we tend not to write it through convention. So in this situation, that has 4 terms. Oh my goodness, 4 terms. So we've now got some language with you, terms, pronumeral, constants, coefficients, equations, expressions. Woo! Now, if you're finding this confusing, and some people say, my God, you talk fast, stop it. The great thing about videos, go back, stop it, think about it, look at the screen, download the notes from mathsguru.com. What else do we need to know? Okay, so I'm going to go back to my example of 3x. All right. Now we know, because I said there in a moment, that's the same as 3 xylophones. But mathematically, there is something in between the 3 and the x. Now, what is it? Well, when I send a card to my mum and dad, I will say, hi, Dad, love you. And I'll say, Darren, and kiss, kiss, kiss. Hold on a moment. Those kisses look remarkably familiar. They're multiplication signs. Are you telling me maths is even invading my cards? And that is exactly it. I think of multiplication signs as kissy kisses. Why? Because they actually stick together numbers and letters, or letters and letters. All right, so this here is the same as 3 times x. Oh my goodness. So in future, you may hear me say, what's between a number and a letter? And I'll do this and I'll go kissy, kissy, because there's a times in between it. Because actually, that 3 and the x are kissing. Enough. Too much information. Just chill. All right? Not want complaints from teachers. Right? So that is a kissy, kissy. So the 3 and the x are deeply, deeply in love. And believe it or not, that can expand to things like 3xy. wherever there is a number and a letter stuck together, or a letter and a letter stuck together, that is the same as 3 Kissy-Kissy X, Kissy-Kissy Y. Lots of kissing going on there. We will definitely leave that one there, right? So when a number and a letter is stuck together, there are timeses. What about if I had X divided by Y? Well, we can write that as a fraction. We know that a divide sign can be written in lots of different ways. And that is exactly the same as X divided by Y. Now, when you see this later on in the videos, I will talk about this as bunk beds. And I will say the X is on the top bunk and the Y is on the bottom bunk. Because if you think about bunk beds, there's one person above the other. And generally speaking, I've got a story that I'll tell in another video about how you have to get rid of the bottom bunk first. But just realize that all of these things are equivalent. They are exactly the same. And that's what that equal sign means. So when you see numbers and letters stuck together, you can put timeses in. When you have that divide sign, you can put the over a fraction. Alternatively, if I had AB divided by C, I can write that out as AB is on the top, and then a divide sign, and then a C. So that's taking that division sign, which is exactly the same as, because I know that when two letters are stuck together, there's a Kissy-Kissy, yup. And that's A, Kissy-Kissy B, divided by C. Ka-ching! Now, where is this all heading towards? Who knows? But this language is actually going to become important. Another one to notice or to remember is that when you multiply something by itself, we have a shortcut to know. And this only works when it's multiplied by itself. A times A is written with A with a floaty 2. So in the same way, B times B would be written with B with a floaty 2. That little floaty 2, that power, that index, and I'll always call it a floaty, tells you it's a shortcut for writing A times A. Now the reason this is important to us is if I actually had X times X times X times X times X times X, we're not going to keep writing that out. That's nuts. Math is supposed to be easy. We'd come up with notation to make life easier for us. So what I actually do is I say, because they're all multiplied together, I count 1, 2, 3, 4, 5, 6 X's. And so I write X to the power of 6, right? And listen to what it said there, X to the floaty 6, X to the power of 6. So that there is the same. So floating number notation is really, really important. The last words I'm going to talk about now are sum, difference, product, and quotient. These words are all really, really important. They're used all the time. So when you sum things together, you're actually adding them together. So if I wanted to do X plus Y, that is the sum of X and Y, right? I won't put brackets on there because that'll confuse. Difference, well, if I'm trying to find the difference, then I am subtracting. So I would have X minus Y in that situation. I'm just choosing random letters here. I could have chosen any letters in the world, but if I'm looking for the difference between X and Y, I would do X minus Y. Product is times. All right, so the product of two things, let's stick with the same letters. If I've got X and Y, then I am working out the product of X and Y, and the quotient, strangely, is divide. All right, so if I want the quotient of X and Y, I'd be doing X divided by Y. All right, again, this example is taken from the Cambridge textbook series, so thank you very much for Cambridge. The question says, list the individual terms in that expression. All right, so list the individual terms, and this is a trick because you've got to put the plus and minus signs in when necessary. All right, so if I was going to list the terms, they are, so the first one would be 4A. Then I'd be looking at this one here, and that plus is really important. Now, convention is we don't write a positive in front of anything. The next term would be minus 12C. So minus 12C, that minus sign is really important. And then the plus 5. Again, convention states I don't need to write the plus, and there are my 4 terms. So we should have known there was 4 terms because there are 4 things separated by a plus or a minus. Next one says, in that expression, state the coefficients of A, B, and C. All right, so the coefficients of A, B, and C. Oh, the coefficient of A, well, that's the number stuck to the A. There we go. Well, the number stuck to the A is in fact 4. So that's a nice and easy one. So the coefficient of A is 4. What about the coefficient of B? What on earth is stuck in front of the B? Well, wonder what's the one number we don't have to write. The one number that we tend to miss out. 1. So actually, the number in front of the B, we don't have to write. When there's just one of something, again, convention states, we just write 1. What is the number in front of C, or what's the number stuck to the C? Again, a lot of people say 12, and it isn't, because we've got to take account of the negative sign. So the C would be negative 12. Oh, storming through this. What is the constant in that expression? What is the constant in that expression? We're not tricked by this anymore, thank you very much, because the constant is the thing without a letter. And so in which case, it's just going to be 5. I could write plus 5, it wouldn't be wrong, but 5. State the coefficient of B. Well, there we go. We're done for that example. All right, so we're now going to do some expressions, and the language here is really, really important. Start relatively simple. The sum of 3 and k. Well, we know what the word sum means. The sum basically means to add. Now, when we add things, the order is not important. 2 plus 3 and 3 plus 2 are the same. So in this situation, we're going to start easy, and we're just going to do 3 plus k. Now, you could do k plus 3, exactly the same answer would ensue, all right? But order for these things is actually really, really important. Next example, the product of m and 7. Now again, order isn't necessarily important. What I mean by that is, what is 2 times 3? We know that's 6. What is 3 times 2? That's also 6. And we know that when we have multiplication, we can change them around so long as they're multiplied. As soon as we put a plus in there, we don't. But so as long as they're stuck together, we can change the order and it makes the same. So you could write this as M7. You could, which is a motorway in the United Kingdom, but anyway. Convention states with maths that you always, where things are multiplied together, write the number first. And you'll notice that here. For all of these examples, for the 4a and the minus 12c, the number was first. So it's preferable to write 7m. They are exactly the same, and you shouldn't be marked incorrect for them, but your teacher may well turn around and go, yeah, I don't think so. Yeah, write the number first. Now this is where they start to get a little bit more tricky, because it says here that 5 is added to 1/2 of k. So there is an order in which you have to do these first. All right, there's an order to them. 5 is added to 1/2 of k. It suggests that we would have to work out what 1/2 of k is first and then add the 5. That's inferred. And I think a reason a lot of people find these difficult is trying to infer the order. So what's 1/2 of k? Well, that's just the same as saying half of k. So I could say half of k. That's a half of k, right? So whenever there's a word of in maths, we can have the word times, which is simplified as a half k. So that's actually can be written as a half k. So that's that bit there. Then what do we have to do? 5 is added to it. So having done that, I can then add 5. And so there we go. That's my answer, half k plus 5. All right, so again, here's another tricky example. The sum of a and b is doubled. So again, there's an implied order there. It wants you to sum a and b and then double the answer. Now, if you've watched a previous video where I talked about the trapezium and how to find the area of the trapezium, this is going to be giving you a bit of a trick. And because we have to make sure that we use BIDMAS, all right? And you're going to go, BIDMAS? What's BIDMAS? Isn't it BODMAS? And I'm going to go, no, it's BIDMAS. All right, here we're going to make great use of brackets, which is going to tell us that that's going to imply an order first. So A and B is summed. So let's do equals. So I'm going to do A plus B is summed. Then it's doubled. So we have to make sure that they go in brackets to say do that bit first and then times it by 2. Now again, convention states that we would actually put the 2 times at the beginning of the brackets, and those are both the same. Now I want you to just see the difference here between A plus B times 2. Now, lots of people would have written that down as an answer, and it isn't correct. And the reason being is, in this situation, that times by 2 only belongs to the b. Because if you looked at BIDMAS, are there any brackets? No. Is there any indices? No. Division? No. Multiplication. So you'd have to do the multiplication first, which means you'd only actually do that bit first. Well, that's not what it wants. It wants the a plus b and then doubled. So you have to be a little bit more careful. And you're going to make mistakes. The whole point of doing these questions is actually to make mistakes, to learn from your mistakes. You do it, you go, oh, I didn't get that right. Because what it does is it breaks down a misunderstanding in your brain. Because your brain has got something in there that's not quite right or hasn't fully understood it. You make a mistake and then you go, excuse me, sir, or ma'am, or miss, can you please help me with this question? It's not an admission of failure. Just because you can't do something doesn't mean you're stupid. It really doesn't. It helps your teacher go, oh, hold on a moment, something that's really been understood. Probably make them a better teacher as well. And ladies and gentlemen, that is it for this lesson. Thank you very much for watching. Please give me a shout out on TikTok and Instagram or whatever it is you guys use nowadays. Tell your mates, tell your teachers that this channel here. Go download the video, download the lessons, and if not, I'll hopefully see you in the next one. You take care, guys. Bye-bye. Thanks very much for watching, guys. Yes, this is the end of another video. If you haven't already done so, can you click on my subscribe button? Yes, it doesn't mean anything other than the fact that I know that you are watching. Yes, it's greatly appreciated. Otherwise, I feel like I'm sitting here just talking to myself. And then, yes, there is maffsguru.com, of which you can see a still of now. And what is over there? Well, all the videos ordered by textbook, ordered by topic. You can search for the videos. You can download notes, time codes, exam questions, and so much more coming up. Yeah, it's absolutely free to join. So I'm done. Thank you very much. I hope to see you in another video. Give me a shout out to your mates if you can. I just want to make sure that everyone finds maths interesting and easy. All right, take care, guys. See you again. Bye-bye. Stay safe.